Good morning, everyone. Thank you so much for joining me this morning. I am Ned Bellavance. I'm the Director of Cloud Solutions here at Anexinet. And today's topic, we're going to be talking about the AWS Well-Architected Framework and specifically the reliability pillar of that framework. So why don't we go ahead and dive in? So the first question, if you haven't attended any of these previous presentations, the first most common question is, what is this well-architected framework? So in order to explain that, I'll go back in history a little bit. And so when AWS was fresh and new in the world and people were first starting to build production-ready applications on it, AWS started getting lots of questions from the people who are building these applications saying, hey, what's the best way to do this? What's the recommended best practices when I'm building an application on AWS? And in order to answer those questions, AWS developed what they call the Well-Architected Framework. And it's made up of 5 different pillars that represent different areas where you could apply best practices. It also has some overriding design principles at a high level that then influence all the various different pillars. And it's also a series of open-ended questions that you or someone else can ask about your existing application to determine sort of where it falls within the design principles and pillars. So at a very high level, that's what the well-architected framework is meant to do. So as I mentioned, there are multiple pillars to the well-architected framework. There's 5, in fact. And the first of those is the operational excellence pillar. That mostly deals with the day-to-day operations of your application within the cloud. How are you, as an organization, making sure that the application is performant, that you're keeping it at the correct level of uptime, that you're managing the change and monitoring of that application appropriately? Those all kind of fall into the operational excellence. And there is some crossover between this pillar and the other pillars. As you can imagine, operations involve a lot of different components, such as security. How are you operating in a secure way? But security goes beyond just operations, and it really dives into how are you protecting data that's in transit and data that's at rest. How are you securing your applications from attackers and potential DDoS attacks, those types of things. The next pillar is reliability, and that's the pillar we're going to be talking about today. So I won't go too deep into it right now, but obviously reliability has to do not only with the ability for your application to survive failures of particular components, but also that your application is able to meet the service level agreements that you've established for it. The next one is performance efficiency, and you'll notice that efficiency is in there, not just performance, because it's very simple to make a really performant application in AWS or in any cloud if you're willing to shell out a lot of money. I mean, the largest VM size has a few terabytes of RAM in it and like 64 vCPUs. You can really buy as much horsepower as you want to make your application scream. But it's really more about being efficient with the available performance. And that goes into one of the key design principles behind the well-architected framework, which is stop guessing at capacity. And then finally, there's cost optimization. And in many ways, cost optimization works hand in hand with the middle 3 pillars, because a lot of the times, if you want to improve security, increase reliability, or increase performance, there's going to be a negative impact on cost. You're going to end up paying more for those things. So cost optimization is all about reaching a balance between the other competing forces for what you want your application to do and the amount of money that you're willing to spend on that application. So those are the pillars. The general design principles, I just mentioned the first one, which is stop guessing at capacity. There was a time, and if you're running an on-premises data center today, you're still very much in this, that you have to purchase capacity for your applications on like a 3 to 5 year life cycle. you basically have to guess 3 or 5 years down the line how much capacity you think you're going to need, and then maybe add an extra 50% on top of that just in case and make that big capital expenditure. That's not the case when it comes to the cloud. You don't have to buy all your capacity up front because there's a giant pool of capacity that you can pull on whenever you need it. So you don't have to guess at capacity and over provision things. The second is to test systems at scale. And what this principle is all about is because you have this giant pool of capacity, you're able to spin up a test version of your application that's at the same size and scale of your production version of that application. And it allows you to truly test things at that scale and determine if, maybe in previous environments you had something, some sort of testing that was a tenth the size of your production. And so you never got to see what happened when you had 10,000 users hitting a workload, maybe only when 1,000 users were hitting that test bed. And the real bottlenecks came up when you hit 10,000. Well, you don't want to discover that in production. So using the cloud allows you to test systems at scale and then deallocate those resources when you're not testing. Another primary component is the ability to automate to experiment. And what that means is all of the various components within AWS or any major public cloud provider are all scriptable and automatable. You can provision infrastructure and applications using code or the CLI or PowerShell, whatever your automation tool of choice is, but you no longer have to hand provision things. And so that frees up time for you to be able to experiment with new services and new features that exist within the public cloud. I think we all know that AWS basically every week has new announcements of services or service enhancements. Trying to keep up with that is very difficult. You need that extra time to experiment. And by experimenting, it drives an evolutionary stance towards architecture. The application as you designed it on day one is not the same application that you're going to be running in 6 months or 12 months. As new services come available and you determine what the bottlenecks are or the reliability issues are in your application, that architecture is going to evolve, and that is necessary and expected. Of course, you're going to be making the decisions about how your architecture evolves by using a data-driven architecture paradigm. And what that means is everything in AWS streams information out about what it's doing, how it's doing it, how much you're consuming. You have a whole bunch of data at your fingertips that you didn't have previously, and that allows you to make decisions about your architecture that are data-driven and not just a gut feeling. And then finally, all this rolls into the idea that your application or workload that you're running in AWS is constantly improving. It's a cycle of continual improvement. No application is truly done. It's just done for right now, and you're looking to what you can roll out to improve it in the next sprint or the next quarter. So with all that in mind, let's dive into reliability, which is the core topic for today's presentation. The reliability has its own set of design principles that are derived from those larger design principles that govern the framework. The first is to test your recovery procedures. This may sound really obvious, but when things fail, and things are absolutely going to fail, components are going to go bad, you don't want to find out that your application is unreliable in production. It's better to test those failures ahead of time and determine what the issues might be and having a good way to recover from that. Ideally, that recovery is automated. So a human doesn't have to manually intervene and repair whatever the failure was. Some sort of automated process kicks in and obviously notifies someone that it had to remediate an issue, but you don't want to wait on a human being to make that change for you. Another core tenet, and this may sound a little strange at first, but the idea of scaling your components horizontally in order to increase availability. We'll dive more into that and sort of pick that apart and what I mean by scaling horizontally. Again, the stop guessing at capacity comes right back in here with reliability. when we talk about reliability, we're not just talking about the ability to survive a failure. We're also talking about the ability to survive increased demand on your application. If you use guessed at capacity and that capacity is static and you get it wrong, then your application could become unavailable, especially if there was a DDoS attack or you're just having a wildly successful day. And then finally, managing change and automation. That core pillar before about automating to experiment, that's not the only reason to automate. Making changes always carries with it a certain element of risk. It's the reason we have change management boards and have change management process. One of the ways to de-risk that change is to automate the change so you don't have to worry about somebody fat fingering something on Saturday night at midnight when your change window is. We're not always at our best right then. There's also a few key areas that make up the reliability pillar. The first is an understanding of service availability. And just to sort of define what service availability means, it's defined as the percentage of time that an application is operating normally. Now, your mileage may vary on what operating normally is, but you'll usually hear availability numbers like 3 nines or 5 nines to describe it. What do those even mean? So the time scale on availability is usually a year or a month. And so if we're talking about 3 nines, so 99.9% availability, you're talking about 8 hours and 45 minutes a year of downtime that's allowed to still keep that 3 nines. That's only 45 minutes a month, which that could be a little daunting. Only having 45 minutes of downtime in an entire month. That's your whole maintenance and change window right there, assuming that anything has to go down. Now, if you're talking 5 nines, if your business says we need this application 5 nines, now you're talking about 5 minutes of downtime, not for the month, but for the whole year, which is about 26 seconds a month. That's really hard. 5 nines is really hard. When someone says 5 nines, you might want to read the fine print. But also, if the business ever says they need 5 nines, they're going to need to justify that and then spend a lot of money to get the 5 nines that they want. You'll also come up against service limits within AWS. And while there's an almost unlimited pool of capacity in all the different regions, there are limitations on how much you can create in a particular account. Some of those are soft limits. You can ask AWS to increase the number of VPCs you're allowed to create, or the number of a particular instance class that you can create. Some of them are hard limits. There is a hard limit on how fast a individual NIC can push data. That's just a physical limitation today of the hardware. So being aware of service limits really helps you figure out what you need to do from a reliability perspective to achieve the service availability you need. There's also some unique things about networking when it comes to reliability. Part of that is just planning your networking strategy, not having overlapping IP addresses when you're developing your VPCs, making sure that you have enough available IP addresses for all the objects that are going to exist in that VPC. If you went with the /24 because it was easy, you may discover further on down the line that that's not nearly enough IP addresses, and expanding that could be very painful. And then there's also ideas about network connectivity between your application and the larger world. How do you architect in a way that makes sure that something can actually get to your application, whether it's a client or an IoT device? Then we get into the ideas, the area of application design. How do you properly architect the internals of your application to survive failures of individual components? And a lot of time that comes down to breaking your application into services and making each of those services very modular, loosely coupled with other services, and horizontally scaled. And then lastly, there's the operational design. How do you manage your application on a day-to-day basis through operations to make sure that it stays highly reliable? And one of the ones that I mentioned earlier, the automating change, that's one of the things that goes into that operational design key area. So this has all been fairly esoteric. I'd like to bring it into more of a real-world example of how you would apply these design principles within the reliability pillar. So first, let's talk about testing recovery. Now, let's say that you are the cloud architect for a new startup called Custom Crowns. And Custom Crowns is making custom helmets for the newly booming electric scooter market. So you've got an e-commerce site running in AWS to take and process orders from customers. What does that application look like? Well, it could look a little like this. This is a fairly typical deployment of something in AWS. At the very top, you're using Route 53 for your DNS resolution. You're using a content delivery network to handle delivery of static assets and resources. And then within a VPC, you have a three-tiered app essentially that has web servers, app servers, and a database backend. You've split that across two availability zones to improve the availability of your application. And then each of the tiers is using an elastic load balancer on the front end to handle requests, and then it's routing those requests to an auto scale group of web servers and app servers. And the database on the bottom is using synchronous replication. So there's a lot of redundancy baked into this design. A lot of things can potentially fail and it still be thumbs up okay. But you want to test this. And the great thing about the cloud is it's relatively simple to test what happens in a failure. So for instance, you can on purpose just take down everything in one of the availability zones. You can have a script that just kills everything in that availability zone and see what happens to your workload. Do clients notice? Are there components that were sticky to things on availability zone B, and now that that's gone, it's broken your application? And obviously, you probably wouldn't want to do this in production, at least not at first, but here's a way of testing what happens to your application. You could do this with your QA environment, let's say, and then run a whole bunch of tests against it. That's one way of testing, but not everything fails cleanly. I mean, yes, an availability zone can go down, but there's also scenarios where perhaps the application tier in one availability zone goes down, and at the same time, there's an issue with your web tier in the other availability zone. How does your application handle that? Can it still route requests and traffic successfully? Those are the kind of tests, and there's a ton more that you can do, but you want to test the recovery of your application to validate that it's as reliable as you think it is. Automatically recovering from failures was the next design thing that we talked about. And so, I mean, the best failure recovery happens without any intervention from a human being. Obviously, on a big enough scale of failure, you want a human being involved, but if something goes bump in the night, it would be awesome if your beeper or your phone or whatever didn't buzz at 2 a.m. to let you know an EC2 instance has failed. You might prefer that things kind of just take care of themselves in that. So how do you bake automatic recovery into your architecture? Well, one way would be through the use of auto scaling groups. So if one of the web servers in our web tier fails, and just in case you didn't know, the service level agreement from AWS for EC2 is 90%. That's their target. So your EC2 instance should be available 90% of the time in any given hour. So that's a 10% failure rate, basically. That's a little scary. So you definitely want something that's able to handle that level of failure without you manually interceding every time an instance fails. And they actually hit something much higher than 90%, but just understand that's what the SLA is. So we have an elastic load balancer that sits in front of this auto scaling group. So it's intercepting all the requests. And the SLA for the elastic load balancer is much higher. If an individual instance fails, the autoscale group will terminate that instance. So it'll detect that something's wrong. It's not responding anymore to probes, or it's hard halted on something. It'll terminate that instance, and then it'll spin up another instance in its place, so it's maintaining the level of availability that you need. The clients are none the wiser. Their requests still go through. They get routed to the available instances while that one is being replaced. Now, it's also important to set your scale factor appropriately. So what do I mean by that? What I mean is the ability to scale horizontally. So there's many reasons to pursue horizontal scaling. And from a performance point of view, it lets you seamlessly scale out and back in as the demand for your resource changes. From an availability standpoint, it allows you to have excess capacity in the case of a failure. And it also changes your failure domain. If you think about ways that you might have scaled in the past, when you had a limited number of virtual machines, you might have just added more capacity to those virtual machines. So I've got, two VMs that make up my web tier. They're getting hammered. I'm gonna, in a maintenance window, add some more memory to them, or another CPU, whatever the bottleneck is. But I haven't changed my availability of them. I haven't changed my failure domain, because if one of those instances goes down, that other instance has to pick up all the slack for it. Not only that, but uh, the availability of those two instances is tied to your data center most likely. So it's keeping those things in mind. It's better to spread out horizontally across more instances so that any individual failure doesn't impact you as significantly. And in the case of AWS availability zones, each availability zone basically represents a data center. So if you have your instances spread or your service spread across multiple availability zones, the failure of a single data center doesn't necessarily negatively impact your application either, because you've designed for that from an availability and reliability perspective. So let's say the other component is the ability to keep your service levels when a failure does occur. And so we kind of talk about that as an N plus one or an N plus N, a level of availability. So let's say we go back to our example of an auto scale group. And let's say, as the administrator for custom crowns, you know that you need an average of 4 instances running to handle average customer load. Now, if you have a failure in one of those instances, now the other 3 instances have to handle the traffic that's normally handled by 4. And you might start dropping sessions, or the website could start getting very laggy. You can imagine that you could lose some customers that way. So one of the ways to deal with that is, rather than having 4 running all the time, instead have 5 instances running all the time. And if one of them fails, you still have 4 up. So you can handle that failure without violating the SLA you have with the business and the customers. Service levels are maintained with that component failing. The other thing to keep in mind with horizontal scaling and the auto scaling is, let's say that your marketing department at Custom Crowns runs a new marketing campaign and it spreads like wildfire. Customers start slamming your site. 4 instances is not going to do it. 5 isn't going to do it. By setting up auto scaling and horizontal scaling and making it automated, now if capacity demands increase, you can add 4 more instances or 40, depending on the level of demand. Now your potential customers still are able to put in their orders or interact with the website. They don't have a bad experience, and you make the marketing department look like a bunch of heroes, which, I mean, of course they are, right? So that is another core tenet of the AWS reliability pillar, that ability to scale horizontally, restrict your failure domains, but also handle increased demands for capacity. And ultimately, it gets down to stop guessing about capacity. Now, we're still guessing a little bit when we're using EC2 instances. We're guessing that we can handle whatever the EC2 limit is for our account. We're guessing that the instance size is appropriate. We have some historical data to back that up, but wouldn't it be nice if you could use services that were more scalable? Because when you're using something like EC2 or even RDS, it has service limitations on how much it can scale and when it can scale. It also places the onus on you to have the appropriate level of reliability and capacity for your service levels. You could choose to update your application using platform as a service, and then a lot of that capacity guessing goes away. So let's kind of look at what a potential alternative would be. So For the website hosting, let's say instead of using EC2 and RDS, we use some of the serverless features that exist within AWS. So we use Amazon S3 to host static assets. S3 is almost infinitely scalable. It handles thousands, millions of requests. You don't have to scale anything. There's nothing you have to tweak to scale it up or scale it down. It just handles the requests as needed, and you only pay for the requests as they happen. So that's sort of the concept of serverless. For the dynamic portions of your application, you've got two sets of Lambda functions set up. One that's handling traditional web tier services and one that could be handling app tier services. Those are exposed through the Amazon API gateway. Again, Lambda scales way up and way back, all depending on the number of requests that come in. And so the more requests that come in, the larger Lambda scales, and then it scales back down to nothing when it's not getting a call. So that dynamic scaling keeps you from having to guess at capacity. And likewise, DynamoDB now has the capability to have dynamic scaling as well. So it can scale way out if your marketing department runs that big campaign and you get hammered. Those requests will be written to DynamoDB, no problem. And then if the tide dies down and you go back to normal levels, the performance in DynamoDB can dynamically scale back. So the whole idea is, how can I adopt my application to stop guessing at capacity and improve reliability? The other good news is, basically, when somebody asks what's the SLA for this application, you can just look at the SLAs for all these various services from AWS and say, well, that's the SLA. It really takes away some of the work that you have to do to improve reliability. The last of the design principles was doing change through automation as opposed to manually changing things. And so let's say you have your autoscale web tier group. We're going back to that previous example. And you're planning to adopt an updated version of the autoscaling group. You want to, version up the application to a new shiny version of the website. Do you know what the single largest cause of downtime is when it comes to applications? It's not component failure, it's people. People break stuff all the time. I know I do. I'm a terrible typist. I fat finger things all the time. It's usually people doing things manually and missing a key step, not reading the directions all the way, fat fingering something. A lot of change windows usually happen late at night when people aren't thinking their best. Changes are one of the riskiest things that you can do. And when people are doing manual things to implement those changes, things break. So let's kind of go through, how would you update this web tier? Well, you could connect into every single instance in that web tier and manually update the application. That's 4 manual changes. Lots of potential for error there. Well, instead, what if we update the base image that this autoscale group is using, and then have that roll through and update the version in the autoscale group? Okay, that's better. We've only had to make one change, so less potential for risk. There's also a user data file that defines the script that runs when these come up. So rather than updating the image, which is a little bit more work, we can just update this script. And then that can go and relaunch each instance and apply the update. Well, that's even less change, because now instead of a whole image, I'm just updating one script, but I'm still doing it manually. And there's still that potential for me to do it wrong. So how could you do it in a way that lowers risk and improves reliability? Well, let's say that you have codified the deployment of your application in a file, and that file is sitting in source control management. When I update that file, I can kick off a process that goes into my CI/CD pipeline. That drives the change to development first, does the upgrade, and then it does a series of tests for that upgrade to make sure that my application is still functioning appropriately. Awesome, right? Dev passes. Then I run that same exact process against QA. I know it's the same process because I don't have to do anything manually. I just kick off the next process. It runs this same change against QA, and then runs the tests again. If everything passes, I'm feeling good. I run it one last time and I upgrade production. So I've made 3 changes. They're all fully automated, and I've really lowered the risk and done a bunch of additional testing to make sure that the change that I want to put into production has been validated twice over. And when the change is actually implemented, no one's typing out commands or trying to follow a step-by-step script. You're just having an automated process make that change for you. It's a huge difference, and it'll make your applications that much more reliable if you can put it in place. So that's the reliability pillar in a nutshell. You could do a whole day on this, but I don't think anybody wants to sit and listen to me talk for a whole day. But you might be thinking of a workload that you have today in AWS or another cloud, and you're kind of thinking, am I following these guidelines? How could I improve? Am I well architected? AWS got this question a lot. Am I well architected? Am I following best practices? Can you help me out? And so what they started doing was these well architected framework reviews. And basically they would have an SA come out and perform the review. But AWS has only so many solutions architects. So what they did is they opened up the well architected review program to certified practitioners. So practitioners who are part of this program are AWS certified partners who have gone through the well-architected training and have their professional level cert for AWS. And basically what they do is they'll work with you. They'll take a look at an existing workload that you have, and they'll go through a series of open-ended questions to analyze that workload against the 5 pillars in the well-architected framework and the design principles that exist. From that working session, the practitioner will create an analysis of what they've learned compared against best practices, and either, green check mark, thumbs up, you're meeting this particular design principle exactly as you should. Yellow is some room for improvement, and red is you should probably change this as soon as possible, especially, if it's something to do with reliability or security. That analysis gets put into a full-on report that you receive that has all the findings from the analysis, as well as suggested mitigations for improving your level of well-architected. And so you get that in the form of a report and also as a PowerPoint and a presentation. So that's pretty cool. In terms of what's actually involved, so let's say that you were interested in doing this, and Anexinet is one of about 40 well-architected partners available worldwide to do this. What would be involved? What would you have to do? From a resourcing standpoint, pretty straightforward. As Anexinet, we would provide a certified well-architected solutions architect, which is architect twice, but so they've gone through the training program. They know the framework backwards and forwards. They can, help you examine a particular workload. You as the customer just need to bring any subject matter experts or application owners for the workload that you select to do the analysis on. In terms of a time commitment, that working session is usually about half a day. Generally, we prefer to do it in person because it's more interactive, but it can also be done remotely. But it's a half-day workshop. There's a little bit of homework to do ahead of time, but you do the half-day workshop with the certified architect, and then we would compile the report off-site, and then do a 1 or 2 hour presentation to review the findings that are in the document and all the suggested remediations. Of course, the question always comes like, how much does this thing cost, right? The good news is it's free. So AWS has never charged for this, and they told all the people all the partners that are participating in the well-architected program, you can't charge for this either. This is a free service for people who are trying to do stuff in AWS and want to do it right. There are also some possible AWS credits that you can get back. So if you engage with Anexinet, we do the well-architected review, and there's some mitigations we suggest. If you then engage with us to do the mitigations, there's a potential to get up to $5,000 in AWS credits for working with us to do those mitigations. So I mean, it's a great positive for us. We get to help you out improving your workload, and it's a great positive for you. You get to figure out if there's ways that you can improve on any of the 5 pillars for a workload you have today. To talk a little bit about Anexinet, who we are, what we do, if you're not familiar with us, our big tagline is everyone deserves a great digital experience. And you can't have a great digital experience if your applications and the supporting architecture aren't well architected. We believe that very strongly. We take a workload-centric approach to everything that we do. There's a couple other things we do aside from cloud and hybrid IT, which is the group that I'm part of. We help design front-facing applications to increase customer engagement. We help develop enterprise mobility strategy and applications for your backend users. And we also have a business intelligence and analytics practice that takes all the information that's coming from these applications and helps you derive value from insights that are trapped up in all of that data that's getting streamed. So that's Anexinet as a whole. At this point, I just wanted to open things up for questions. If anybody has any questions about the well-architected framework, how they could get involved, go ahead and put your questions in the question box, and they'll get filtered up to me. I think there's already one in here. And this is one we get almost all the time. It's how do I select a workload? How do you decide which workload you'd even want to do well architected for? So generally the answer to that is you want it to be a production deployed application that you're deriving value from as a company. So, in our example, the custom crowns, the main website, that's probably one example of an application, but really any application that's, critical to the business, and by improving it, you could help really drive or increase value to the company. That's a good candidate. It doesn't have to be in AWS. AWS would obviously prefer that it is, but it could be running in any environment, whether that's on premises or in the cloud. What else do we have? Okay, how do I figure out my availability requirements? Ooh, that's a tough one. There are whole white papers on determining availability requirements, but probably the most important thing is to understand from the business what their expectations are, and then also understand what the impact is from a financial perspective if the application is unavailable or the performance of the application is degraded. So either one of those are really what's going to drive your availability requirements. But ultimately, it's more up to the business to set that availability requirement and for you as the IT practitioner to achieve it, and make sure that you communicate back how much different levels of availability are going to cost. I mean, the 5 nines example where you get 5 minutes of downtime, that's rough. That's going to be real expensive to do. What's the next one? So someone liked the example of moving a website to S3 and Lambda, and they wanted to know, is there an easy way to do that? There's actually a tutorial, if you will, on AWS's website that'll take you through how to build a website on S3, Lambda, API Gateway, kind of all the components that I showed. It doesn't tell you how to migrate an existing site, but if you're a web developer and you wanted to dive more into that, yeah, there's some good documentation, and there's also some good blog posts out there about how you might go about, constructing this, and some of the gotchas and pitfalls of using Lambda, like the warm-up time, those kinds of things. All right, I've got one more here. I'm interested in the security pillar. Are you going to do a webinar on that? It's funny. Security is probably the hottest button topic out of all of these. We actually already did the security pillar. So if you're interested, I believe you can just go to our YouTube channel, and I think that the security webinar is already up and available on there. If not, just reach out to me or reach out to Anexinet, and we'll definitely get you, a link to that presentation. We've also done one for operational excellence. The performance and the cost optimization are coming. So if this piqued your interest, you want to know more about the other pillars, make sure to sign up for those webinars. I believe we have one in June and one in July for the next 2 pillars. And with that, I believe that's all the questions we have. So I just want to say thank you to everyone for attending today. I know it's sometimes difficult to take a little time out of the day to learn more, but I appreciate that you chose to spend time listening to me. And if you have any questions, I highly encourage you to reach out to me or to Anexinet, and we'd be happy to address those questions. Thanks, everyone, and have a great day.